Welcome. This deck shows how A2A task delegation plus OpenClaw turns B2B RFQ handling from a serial email workflow into a parallel, auditable coding system. The flow is simple. RFQ intake comes in, delegated agents run in parallel, and a ranked award recommendation comes out. Backed by a Docker reference implementation you can actually run. The bottleneck is structural, not a discipline problem. A distributor receiving 200 RFQs a week faces PDFs, portal exports, Excel attachments, EDI messages, and inconsistent schemas, all processed in series. Coordinators manually check catalog availability, contact 3 to 5 suppliers one at a time, normalize responses by hand, and assemble comparison matrices. Manual normalization alone consumes 50 hours a week, 200 quotes at roughly 15 minutes each. 3 structural bottlenecks: format fragmentation, sequential dispatch, and no audit trail. Traditional email-based RFQ cycles run 15 to 30 days. Parallel agent dispatch runs 3 to 7 days, roughly an 80% cycle time reduction. But here's the adoption gap. 94% of procurement executives use generative API weekly, yet only 4% report large-scale deployment and sourcing. The opportunity isn't generic AI adoption. It's finding the workflow pattern that makes AI deployable in quoting. 4 layers, clean separation of concerns. Layer 1, business systems, ERP, e-commerce, shipping, supplier catalogs. Layer 2, MCP connector modules expose those APIs to the agent layer. Layer 3, the RFQ engine and A2A orchestration. The engine owns lifecycle, inventory holds, normalized quote records, and award decisions. A2A delegates subtasks. Layer 4, OpenClaw, the OpenAI-compatible LLM inference backend for parsing, extraction, reasoning, and summaries. The RFQ engine owns workflow state. A2A owns delegation. 1 orchestrating agent turns serial work into parallel work. It reads an incoming RFQ and decomposes it into subtasks: vendor dispatch, quote normalization, availability checking, compliance verification, should cost analysis. Each subtask is an API JSON-RPC message with lifecycle state and streaming support. Task states track sent, streaming, completed, canceled, and failed. So the orchestrator always knows what each specialist is doing without knowing that specialist's internals. 6 steps from intake to ranked award. 1. A human submits the RFQ. 2. The RFQ engine parses it and places a catalog hold. 3. A2A agents dispatch in parallel to 3 to 5 qualified vendors. 4. OpenClaw normalizes quotes from PDF, Excel, EDI, portal, or email formats. 5. Compliance and should cost checks run. 6. The engine ranks quotes and presents a recommendation for human approval. The human appears only at intake oversight and the final award decision. Agents handle preparation, comparison, and traceability. This isn't just a concept. It's a Docker Compose stack that actually runs. The SilvaEngine Gateway carries the A2A daemon module and exposes JSON-RPC 2.0, GraphQL, SSE, and the agent card. The bridge sends tasks to OpenClaw through the OpenAI-compatible /v1 chat/completions endpoint. PostgreSQL persists state and tasks. The image is environment-driven with no baked-in secrets. The reference implementation lives at github.com/IdeaBosque/Docker A2A OpenClaw Gateway. The integration surface is precise. A caller sends message send. The gateway routes to the bridge, which calls OpenClaw /v1/chat/completions. The SSE token stream flows back through the gateway, and tasks get returns completed with the result. A2A operations, message send, tasks get, tasks cancel, tasks list. Model selectors let you target OpenClaw, OpenClaw default, OpenClaw with a specific agent ID, or route by agent ID header. Streaming or non-streaming chat completions depending on configuration. Every delegated task is evidence. The ledger records task ID, agent, input, output, status, and timestamp for every step. Vendor dispatch, normalization, compliance, should cost. Compliance runs in parallel against contract terms, certifications, and supplier diversity rules. The human award decision is the final approved step, and it's reviewable. Every normalized quote and decision factor is attached to the task trail. That auditability is essential for regulated or supplier diversity-sensitive procurement. The business case compounds. Cycle time compresses from 15 to 30 days down to 3 to 7. Faster customer response, less stale pricing exposure. 50 hours a week of manual normalization and dispatch work drops out of the weekly operating burden. Source-to-pay digitization creates 8 to 12% annual savings of total spend, plus 6 to 12% in the initial contract period. The outcome isn't only cost savings, it's a compounding speed advantage in quoting. A credible first build is narrow and measurable. Week 1 is discovery, system inventory, workflow map, source system access, RFQ schema review. Pilot, connect one ERP or catalog source, one supplier channel, one RFQ category. Validate, compare agent-generated recommendations against historical awards. Scale, add compliance rules, should-cost models, supplier diversity policies, and more vendors. Each gate is a go, no-go checkpoint, not a phase you drift through. The next step is discovery, not a generic demo. Scope the RFQ workflow before choosing the automation stack. 1 week of discovery produces a system inventory, a workflow map, and a fixed scope. The architecture reduces to one line: RFQ engine plus MCP plus A2A plus OpenClaw. Request a scoped build based on the IdeaBosque article and the Docker A2A OpenClaw Gateway repository. Every number on these slides traces back here: 200 RFQs per week, the volume scenario from the IdeaBosque article. 15 to 30 days, the traditional RFQ cycle per IdeaBosque and Evalua 2026. 3 to 7 days, the automated sourcing cycle. Roughly 80% cycle time reduction. 94% weekly generative AI usage among procurement executives, but only 4% large-scale deployment, both from Art of Procurement 2026. 50 hours per week of manual normalization. 8 to 12% annual savings of total spend from source-to-pay digitization, plus 6 to 12% in the initial contract period. Primary source, the IdeaBosque article. Reference stack, github.com/IdeaBosque Docker A2A OpenClaw Gateway. For technical reviewers, the repository layout is straightforward. Stack definition: Docker compose.yml for service topology and volumes. Docker file for the gateway image build. Routes.yaml for the A2A route surface mapping. And .env example for env-driven config with no baked secrets. Test coverage spans gateway surface tests, hello flow end-to-end, SSE streaming events, a live bridge to OpenClaw, and chatbot behavior. Bridge configuration is environment-driven. OpenClaw API URL sets the inference endpoint base. OpenClaw API key holds the auth credential, env only. OpenClaw agent ID binds a default agent. OpenClaw agent selector handles per request agent routing. OpenClaw stream timeout sets the SSE stream ceiling. Config priority: per agent metadata first, then forwarded settings, then config class attributes, then hard-coded defaults. First match wins. Later levels are fallback only. A procurement-grade validation lens. Integration readiness. Is source system API access confirmed? Are supplier response formats cataloged? Are inventory hold semantics agreed? Governance and safety. Are human approval rules documented? Are compliance and audit requirements mapped? Are failure handling and cancellation paths defined? Is security and secret handling verified? Run this checklist during week 1 discovery. Each gap becomes a pilot scope boundary.